All right, so we did this in the lecture. Shh. We did this in the lecture, right? But the part we did not cover was figuring out the loss of mechanical energy in a collision. When you have a collision, you cannot say that mechanical energy before the collision equals mechanical energy after the collision, because you lose energy primarily to heat. You know, like we were talking about a bullet going into a block. You stick your finger in the bullet hole is going to be hot. That heat energy came from the kinetic energy of the bullet. All right, so let's just go through the whole problem. So A, what's the velocity of the truck right after the collision? So let's say that the car, we're going to say car is M1, truck is M2. So M1 is 1,200 kilograms, right? M2 is 9,000 kilograms. So we got a collision here. This is before the collision. This is after the collision. Okay? So you can always apply conservation of momentum, which says momentum before equals momentum after. So you go M1 V1 initial plus M2 V2 initial equals M1 V1 final plus M2 V2 final. The only thing that we don't have is V2 final, right? Which is this guy right here. We don't have the velocity of the truck after the collision. So you plug all the numbers in. Well, actually, let's do algebra first. So the algebra is going to be this. V2 final is going to be M1 V1 initial plus M2 V2 initial minus M1 V1 final, right? Take this right here, and I moved it across, and then divide everything by M2. Okay, so look, M1 is 1,200. So M1, you're going to go like this. You're going to plug in. V1 initial is 25. M2 is 9,000. 20 is the V2 initial. V1 final is the 18. And then M2 goes there. So when you plug the numbers in, you find out that the velocity of the truck after the collision is 20.93 meters per, not meter per second squared, just meter per second. That's part A. Now, part B says how much mechanical energy is lost in the collision. So everybody got this part down? All right, let me revert this back. Okay, first off, what do we mean by mechanical energy? Mechanical energy is what? Kinetic plus potential. It's kinetic and potential. Does this situation have any potential energy going on? No, there's no, the only time you're going to have potential energy is if there's a hill or some vertical change, for MGH, or if there's a spring, if there's a spring in the problem. So basically, when they say how much mechanical energy is lost, what are they really saying? How much kinetic energy is lost? That's what they're asking for. So to figure out how much kinetic energy is lost, you got to know two things. What are the two things you got to know? How much did you start with, and how much did you end with? Like, think about if you lose money. If you lose money and a police officer comes up to you and is like, well, how much money did you lose? In order to figure out how much money you lost, you have to know how much you had and how much you ended with, right? So here's what we're going to do. We got to figure out the total initial kinetic energy, which is two-part. We got to find the kinetic energy of the car before the collision, and we need the kinetic energy of the truck before the collision, right? So what's the equation for kinetic energy? 1/2 mv squared. I'm going to let you plug the numbers in. If you do 1/2 mv squared for the car, you get 375,000 joules. For the truck, you get 1,800,000 joules. So what is the total initial kinetic? You add those two together. The total initial is 2,175,000. All right, so then you go to the final. After the collision, the car has kinetic energy, and the truck has kinetic energy. So do 1/2 mv squared. The car has 194,400. And then the truck is 1,971,292. So the total final, you add those together, the total kinetic energy final is 2,165,692. So look, if you compare these two values, did we lose a little bit? Yep. How much did we lose? You subtract them, and it's about 9,300 joules. In this collision, we lost 9,300 joules.